Wonderful. Good day, everyone, and thank you very much for having me. And of course, wishing that I could be with you in person, but we do have to manage with the current restrictions in place. For most, I'm hoping that you, your friends and family are well and safe after the terrible weather you had over the last few days. So let me introduce myself. My name is Carlo Ruiz, and as you just heard, I'm leading the AI solutions business in EMEA. Think of large-scale AI deployments. And so thank you for the invite today. It's great to meet all of you, all the honorable guests at this event. The topic on the agenda today is about the power of AI, the engine, if you will, behind the new wave of economic growth. And I will also give you a short introduction to what we can do with the Nvidia technology, AI in general, the why, its practical applications, and of course, what is next, right? AI at scale. And there are tremendous challenges, right? There are benefits in this space, but also tremendous challenges. They are enormous, and they do require cutting-edge data center technology. And that's something that ODP has mobilized to tackle exactly those challenges. So let's get started. And as an intro, let me talk a bit about the journey that brought us here. Over the last few decades, and some of us have experienced all of these waves, we have seen these, as I call them, waves of change in computing over the last years. And this evolution of computing drives industrial, but also societal change. And each era of computing was triggered by a revolutionary new computing model. So let's go all the way back to '95. The PC internet era kicked off by Microsoft, Intel, but also other names that have gone since then, like Netscape and Yahoo. They made computing available to over 1 billion PC users in the world. Let's fast forward to 2006. This is the mobile cloud era, ignited by developments like the iPhone and Amazon AWS. And this made computing available to 2.5 billion mobile users in the world. And here we are today together, where GPU deep learning is igniting a new wave of computing, where with AI and deep learning, software can learn and machines can start to reason. And so eventually we foresee an environment where we have trillions of intelligence devices. And the era of AI is here. And analysts and industry are aligned. AI will have a bigger impact than what we have seen from the internet and mobile era altogether. So the impact will be massive, and we have exciting times ahead. And AI, as we heard also from the other distinguished speakers, is a once-in-a-generation technology. It's basically the automation of automation, and we can do this automation now at a precision or a speed that was not possible before. And the contribution is massive, right? So we predict a productivity growth of 16% by 2030. And this will impact the nations around the world. And we have seen the details on the impact that it will have on this region. Also, we see that it will boost the global GDP by 16 trillion. So a tremendous impact. And it will also create 58 million jobs. So it will not reduce the number of jobs, it will increase the number of jobs. But this will not be without any disruption to industries, segments, and nations. Things need to happen if we want to ride this wave in the right way. Now, and just to get everyone at the same level, to create some common ground here today, I wanted to share just a few words specifically on deep learning. And deep learning is a specific field of artificial intelligence. It relies on the training of neural networks versus what we had in the past, hand coding, feature extractors. So deep learning in specific is very exciting to all of us because there are challenges that were extremely hard to code. And one of my favorite examples of the work that we're doing at Nvidia is what we do around self-driving cars. Now, making a self-driving car is a very hard problem. It's extremely hard to code. So if we look at the general process, and you see a diagram here on the screen, it kind of looks like this. Let's say we need a neural network to recognize traffic signs. In a car, you will have many neural networks, but let's take this example to recognize a traffic sign. We start training a neural network with many images, with many situations, with many conditions, lighting that might be specific for a location. And after the training, we'll end up with an algorithm that recognizes pedestrians with a certain accuracy or traffic signs. And once you have trained that model, then you start serving that out, the inferencing, or inferencing to lead to conclusions after receiving specific input. And you know this process, right? So the inference, maybe you do voice recognition on your phone, or you use song recognition with the Shazam. All of that is first trained and then served out. And in this car example, when we serve it out, it will sit on a car computer, an Nvidia car computer, like the ones that we make for Daimler to be hosted in all the future Mercedes cars. Now, to get such an algorithm to perform at 80% accuracy, that's not hard, right? I'm not going to say it's easy, but you can get something done on a PC like that, and you will have 80% accuracy. But obviously, those numbers are not great if you had to operate a real car. I can imagine the government of Oman not liking a car on the road that has 80% accuracy, right? So the hard part is to get to models which have 99.99999% of accuracy. And then you need to have more data. And the environment will start to change. So as you can see, this deep learning opens up tremendous opportunities, but it's also a cycle that will never end and just gets more complex. And that's why technology is such an important enabler. Which raises the question, what is then the technical contribution that Nvidia delivers in accelerating AI? So why do we see this very strong uptake and the adoption of Nvidia GPU computing over the last years? Well, imagine this, if you were a researcher or a developer in the past and you would be working on conventional CPU technology, then you could always count on Moore's law to give you more performance, to give you more headroom, to realize new breakthroughs in your projects without having any major changes. And you can see the CPU performance in the graph here in blue. And so you could always count on Moore's law to give you this extra push and work on a breakthrough. But what we have seen right now is that we're running into the physical barriers and limitations of single transistors. And suddenly that progress is not there anymore. So you can see this performance is plateauing. And there's no way of powering innovation based on the conventional technology. Now, Nvidia GPU technology on the green line was never designed to count on the performance increase of single transistors processors. And let me move back here. And it is set up that it works in a highly parallel fashion. And so we see this exponential growth of performance power that we deliver. And the delta between the two has become enormous over the last 10 years. So if you want to power tremendous breakthroughs, GPU technology is the engine for this. Now, why does all of this matter? Because the combination of three key elements, which you see to the right, have ignited this big bang of modern AI. One, deep neural networks. It's not a new concept. They have been around for decades, and historically they didn't perform well. But the concept works extremely well. But it was missing the part in the middle, large data sets. And the internet era brought us large labeled data sets. And then the last element that was missing is the GPU technology to power, to have the compute headroom to calculate everything and bring it together. And so we saw the first great benefits of this in 2012 with AlexNet, one of the first examples of AI outperforming conventional compute. And that just happened on 2 GPUs. And the rest is history. Let's move on. So we like to underline that AI is writing software that is achieving results no human written software can ever deliver. So this approach is also very scalable. Scalable in several ways. It's scalable across domains. It's also scalable to take on larger challenges with more complex models. More training, more parameters, more capable. To the left here, we see a chart illustrating the compute resources leveraged for cutting-edge AI projects. It's the number of days to train on a 1 petaflops computer. So on the left bottom side, you can see AlexNet in 2012 requiring 2 GPUs. Now, over the last 5 years, we've seen the requirements go up with 30,000x, and the largest supercomputers to power this are doubling every few months. But the results are simply amazing. So to the right-hand side, you see some examples. At Nvidia Research, we have run a project where we're reading 30,000 text passages, and then someone needs to answer 100,000 multiple choice questions. The average human scores 73% in this test. If you have an extreme expert in these texts, he will score 95. Or AI model called Megatron scores 97%, outperforming any human. The one next to that is Facebook. They have created a very, very advanced chatbot. And guess what? Over half of the users, they prefer the chatbot over human interaction because it's simply better and more tailor-made. Let's move on. We also have great scientific breakthroughs powered with this. So DeepDrive MD and NMD have won a special Gordon Bell Prize for their COVID-19 research. They used converged simulation and AI to understand the COVID virus and how it infects a human cell. The work that they have done with this was done on one of the largest Nvidia-powered supercomputers, where it would take normally over 100 days to do this calculation. They did it in under 2 days. And this work has been the basis of a lot of other research, and over 4,000 other COVID researchers have leveraged this work. So showing the benefits and the dramatic impact that AI can have. So AI and deep learning in particular turn out to be stunningly effective across many domains, being true engines of change. And they're transforming the way that computers achieve perceptual tasks such as computer vision, pattern detection, speech recognition, and behavior prediction. We've seen great examples in internet services, AI assistants, social networking, recommender engines in e-commerce. Medicine, I mentioned, healthcare, COVID-related breakthroughs, and the ability to move to a proactive instead of reactive healthcare approach. That's a true game changer. And here in GCC, we have a customer using our technology to do DNA sequencing of over 1 million people to move from this reactive to proactive healthcare approach. Then media and entertainment, we're all using that every day with movie and music recommendations. And security and defense, you can imagine all the use cases, both in the virtual environment, but also in the physical environment. And then autonomous machines, drones, and delivery robots. It's truly changing the face of the earth. Now, silicon, hardware, chip, GPU technology is an important foundation to our ecosystem. And yes, it's very important to go in detail there. There are some great options to leverage when you go for AI at scale. But next to the underlying compute, even more important is the rest of the stack, the software, the libraries to leverage this new compute performance in your favorite developer tools, your own applications. And specifically all the tools that researchers and developers can do to create their own work. And so we spent at Nvidia much of our developer efforts in creating these building blocks for others to leverage. They can stand on the shoulders of our researchers. And on the right-hand side, you see some examples of industry-specific SDKs that we make available. And we do much to accelerate the work of others there. Let me give you some in detail examples. So conversational AI, and we heard Jaap just speak about the potential of working with Arabic natural language processing. Nvidia has building blocks so that one can focus on whatever one tries to achieve with NLP and doesn't need to recreate the whole foundation. Recommender systems for e-commerce. Only the smallest improvement possible already yields tremendous revenue opportunities. Smart cities making smarter, more efficient cities, and also keeping our residents safe. We have great toolkits with Metropolis to power, for example, intelligent video analytics. The Clara toolkit is all about healthcare. So we have these building blocks that can help to accelerate medicine discovery, or, for example, power medical instruments. The foundation is already available, and to then develop the domain-specific addition on top. In robotics, we have Isaac for simulation, for reinforcement learning of robots, and also for deployment. An example of that is how we work with BMW on the future of factories. Autonomous vehicles, we're working with many auto manufacturers across the world, both for the training and also to completely deliver the inner works for the self-driving cars, like we're doing for Mercedes. And the last one that I want to mention here is what we can do for telco, for 5G, for smart deployment. Now, as you can see, much of this is about supporting scientists, researchers, developers, creators that are leveraging our technology. Today, we have over 2.5 million developers and over 8,500 AI startups that are creating thousands of applications a year that take advantage of accelerated computing. And to date, I'm very proud to share with you that we have shipped over 1 billion of these CUDA-capable GPUs. So from our point of view, much of our work is focused on empowering the developer ecosystem. And developers, they need the most advanced tools so that they can leverage environments as they are available at ODP. Now, as you already noticed, we talked quite a bit about AI. We learned about its amazing results. It started small, but it's also fair to say that some of the key breakthroughs were realized on some of the largest AI compute environments in the world. So as we see larger models, larger projects, the challenges are growing. The challenges do not fit in a single processor anymore. They don't fit in a single computer, but the cluster, the data center becomes the new unit of compute that we should think of. For that reason, you have seen us active in all kinds of acquisitions in the industry and the expansion of our technology. And much of that is created internally as tooling that we use for our own R&D. So some of our leading AI platforms, such as the DGX that was mentioned before and is a key engine in Nebula AI, they are not born as a commercial product. They are born as an internal tool. Our own IT infrastructure built on DGX that is powering some of the most important work. And you see examples at the bottom of the screen of some of the research projects that it's powering. This cluster we call Saturn V. It's a big cluster of DGXs, and it had many expansions over the year. So we make that now available as a turnkey platform together with ODP to developers, to researchers, and our partners to benefit from all the revolutionary performance, the possibilities that we have developed in-house. And it's absolutely industry leading. Let me give you an up-close view of this. So, and as I said, we used to think of a CPU server as the basic unit of computing. But to meet the demands of today's machine learning and AI workloads, we must optimize the entire data center. And the new unit of computing is the data center powered by these DGX A100 AI supercomputers. This is one of the great engines that you see here. And just to give you a little bit of a perspective what that means, just in 2011, on the left-hand side, this kind of performance, 10 petaflops of compute performance, was only available in one location in the world. It came at tremendous cost and available to very, very few researchers. And it had an unbelievable power consumption. As you can see there, 12,000 kilowatt or 12 megawatts. Today, ODP has in Oman a DGX-powered AI cluster with 10 petaflops of performance, enabling breakthroughs, and not just for the happy few, but making that available to local organizations, bringing high performance to those that can benefit from AI adoption and make a difference here to the nation. And it comes at a fraction of the cost. It becomes affordable, and a fraction of the energy consumption, making it sustainable. So this is about democratizing AI in the best possible way. Earlier we talked about it's not just technology, right? So there are pillars to bring a nation forward with AI. But having the technology infrastructure is a keystone to a complete ecosystem. So starting with access to large-scale, state-of-the-art GPU-accelerated computing systems, you can start to work on research from universities, startups, and your local industry. AI will accelerate job growth, but it also requires the right skills and expertise to be able to develop on these platforms. So countries such as Oman need to invest in training and education programs that add AI skills to the workforce. By investing in your key industries, countries have a unique opportunity to drive this growth and solve some of the greatest social and economic challenges. The time to do so is now. And here you see the practical implementation, and I'm very happy to be here today at the launch of this great initiative. Together we bring technology, expertise, investment, and the industry solutions, the building blocks to build upon. So that brings us to the wrap up. I think we can fairly clearly conclude that artificial intelligence is the most powerful technology force of our time. It requires technology, it requires infrastructure, it requires software, it requires these building blocks, it requires the building of an ecosystem. With a strong cooperation on a local level, on industry level with innovators in their domain, that will happen. And so we're very proud to be teaming with Oman Data Park, to work with Maqbool Awahibi and his excellent team at the organization. And together we're ready to enable the next generation of researchers and developers in Oman. And I'm inviting you here today, please reach out to our teams, reach out to me directly, reach out to our team on the ground, and let us help you to get the most out of this new AI center at ODP. Thank you for your attention this morning.